In this video, I will be going step by step through the process of getting you up and running with YOLOv5 and creating your own custom training and detections. After this tutorial, you should be able to create your own custom detections on your Windows machine like what I'm showing here. Let's go ahead and get started. There's two ways that we can set up the custom detections. The first way is to use the Google Colab, and the second way is to use the local machine. So it depends on what kind of computational resources that you have. But before we can train our own custom models, of course, we need to assemble a data of image. We need to create the data set with the bounding box annotations. At the same time, we also need them to be labeled, and of course in YOLOv5 format. In that case, there are many options for us to create our own data set with the bounding box, with the labels, and of course in also YOLOv5 formats. But for the sake of simplicity for this tutorial, Roboflow, that is the online tools that we are going to use to prepare the labels and also to host our custom data. First thing first, we need to collect the image to train our models. Training on an image similar to the ones that you will predict is very important. Ideally, you should collect a wide varieties of image with highly similar configurations as you will ultimately deploy your project. Because we are going to apply the YOLOv5, and we are not building the model from the ground up. 200 to 400 image per class, that would be a very good starting point to train our initial models. Let's take a look on this example. What we're going to do is to detect a class license plate. So just open the Google and then type class license plate. And of course, in this case, we would like to click on the image. So just in case, if you have these extensions to download all image, and then you can just download all image in a zip file once. And of course, this is just one example because normally you should have your image prepared. So after clicking the zip, you can see that there is a zip file that contains all the image showing here. So you can just use it to train your models. Now we have the image, we have collected the image. Of course, we now can prepare the image dataset by annotating the objects, labeling the objects. Again, it's just like what I mentioned, Roboflow is the tools that we are going to use in these tutorials. This is a online or web-based tools for managing, annotating, and labeling the image. And then finally, of course, it also allows us to export the image in YOLOv5 format. So what we need to do, of course, is that we need to sign up and or create a free account with the Roboflow. Once we have this account set up, we can then open the YOLOv5 custom training notebook. And here we go. And I will also provide a link in this notebook. You can just click on it and we will just get through there. Because this is a file under the Roboflow, in that case, we would like to save a copy in our own drive so that later on we can continue to fine-tune the models or continues to build our custom trainings in our own model. In that case, just click on the file and then save a copy in your own drive. And then, of course, you can rename it to whatever you want. And this is the file that I just saved it in my own drive that is called the YOLOv5 plus Roboflow custom training notebook. And now, first thing that we need to do is to install the requirement. You just click on there's nothing you need to do, just click on the play button. And it will help you to clone the YOLOv5 report and also install the requirements and also install the Roboflow. And also, of course, you can check what kind of free GPU resources that Google Colabs provides to you right here as well. And now we are ready to assemble our own dataset. Remember that we are using the Roboflow. So in that case, of course, we can just from Roboflow, we're going to import these libraries, these frameworks to help us to perform the custom training. And we just play these buttons, and each should provide you a link here. So you just simply click on the link, and it will just redirect you to your own account. Now, let's say if I want to sign in with my GitHub, and normally you will see a prompt that is like this, train a custom model. What you need to do is just to click continue. And once you click continues, you can then either create a new project or load an existing model. Let's say, for example, if you click on the create new project, you should, what you need to do is to input the project name, and also what you need to do is to put in the annotation group that you would like to put it in. So here I've already have that, so I would probably give it a pass. But what you need to do just to provide the field, just fill in these two fields. And then once you have that, you have that project set up, you can upload your own image. For a new project, what you need to do is to upload your image and select the files, select the folders that contains your image, and then finish your uploading. Once you upload your image, there are a few options that allows you to split the image. So say, for example, you can split your image between the training, validations, and also testing set. Or if you already have a very large image data set, you might just want to add your image to your training set, or you might just want to add your image to a validation set or the testing set. And the default ratio here is for the training validation test is very good starting point, that is around 70%, 70% for training, 20% for validations, and 10% for testing. And on the other hand, for existing projects, you can click on your existing project and then click the upload, and here you can select the file or select the folders to continue your upload. Once you upload the image, of course, you can just also put it into the training set, validation set, or the testing set that fits your needs. And then we can click on the image and then start to annotate each of the image. Say, for example, for the car license plate, for this one, I just let this car license plate and then press save and enters, and the annotations has been completed. Once you annotate all the image, now you are ready to generate a new versions of your dataset to train a model. In that case, there's a buttons over here, green buttons over here. You can just click on it to generate the new version. what you need to do is click on this Generate New Versions button, and then you need to check if the dataset is correct, and also the training, validations, testing datasets need to be rebalanced or not, or that is correct already. And of course, you can then just check if the pre-processing fits your needs, the auto-oriented fits your needs, the image size, whether or not it fits your needs. By default, 416 is one of the 416 by 416 if the one of the size that fits YOLO training. And you do not need to turn off you do not need the augmentation, so you can just turn off the augmentations, and then finally just click on the generate new image, and you are ready to generate a new version. This will take you a moment, and of course then you can just save a name for it, and then you can just save names and then export. And under the export, what you need to do, say, let me do the save names and then export. Under the export, what you need to do is to select a YOLOv5 PyTorch and select the show downloads code over here, and then continue. And it will create a zip file for you, and then of course it will help you to generate the code. Now you should have this code right here. Remember, what you need to do is to copy and paste this code. So here, just Control-C to copy this code first. Once you've done, we can then go back to the Google Colab and paste the code in the cell highlighted and run the two cells. So Control-C and then go back to the Google Colab, and for this cell, set up the environment, run this cell, and what I need to do is to paste everything over here and run this cell. Now we are ready to train the models. There are plenty of arguments that we can pass for custom trainings. Well, if you want to go through the details here, you can just take a look on my notebooks over here. I will also upload to the GitHub for your own reference. Let's focus on a few key arguments that includes the image, because this is the image input size that it has to be aligned with the training set. Remember, what we are using is a 400. Let me show you. Remember, what we're using is that 416 by 416. So here we need to make sure that the input image size align with this step. So here for your own reference is that image 416. And you can, of course, define the batch size. So it all depends on how large your data set. And the larger the data set that you have, you might want to select define a larger batch size to speed up the training. And of course, you can then define the number of training epoch. Here I will use 150 as an example. And the data is already loaded to the specified location, so you do not need to change any code over here. And then for the cache image is that is just for you to speed up the training. And finally, you can change this weight to fit your purpose. And there are quite a number of YOLOv5 pre-existing models that allows you to continues to train it on. And so, for example, here we are using the YOLOv5X, and of course you can use some large YOLOv5 models if you want to have a much higher accuracy predictions. But of course, while you when you're deploying the models, the inference will be a little bit slower than the light one, than the light version. So once we've done the training, so we just need to start the training with the following commands. And once you complete the training, and there's two models that have been saved. And the first model is the last models. This is the 14 line. This is 140 line models. This is the last models. That means once you have this model, of course, if there's anything that stopped your trainings, if you want to continue to build your models based on these last models, and it's already in your YOLOs in these folders, and then there's another one that is the best models. Normally, if we've completed our trainings, and we will have a early stopping over somewhere, and in this case, it will depend on the validation set. And in this case, this is the best models. So we also YOLO will also help you to save this best model under these folders, and everything will be saved into these folders, and your models, and of course some results. So for the validation results, it will also save that in the run, trained, and expert exp files, and for your further evaluations. Excellent. Now we are ready to evaluate our custom training models. Of course, at this point, you can also take a look on the MAPs to see whether it's already satisfied your needs. And of course, you can also evaluate the custom YOLOv5 training process. YOLO's custom training use the TensorBot and allows you to use the TensorBots to take a look on how your models performs during the training. So you can take a look on that. And regarding the performance, the one that you want to focus is MAP 0.5 in your validation dataset. And remember that the best model is already saved accordingly. Now, finally, of course, you can run your inference with the training models under these Google Colab. You can just click on the play, you can see all the trained prediction or all the inference has been rendered in the Google Colab. On the other hand, of course, you can refer my previous videos on the YOLOv5 to see how we can do the predictions, and you can just put everything, you can do the inference within your own local machine. Now, what we need to do over here is to run the first cell to, here we go, run the first cells with the pre-trained models, and then so of course with specified path over here, you need to specify the rate path, you need to specify the image size, and also with you need to specify the image or the source that you want to make the inference. And again, results, you can see the results over here, and also you can see the results in the saved file. There should be a saved, yep, here we go. YOLO will help you to save the file over here in the Google Colab. And just in case if you've run in your local machine, of course, it will save that under your local machine. And finally, say for example, if you want to do the inference under your local machine, what you need to do is to download your models. Once you save and download your models, and then now you can deploy your model on your own for your own applications within your local machine. Then what you need to do is to put your model in a specified path and to keep the path aligned with the Google Colab. As an example, you can put the best models into the YOLOv5 ones train, exp, and wait. And just put it into these folders. And of course, just like what we've done in the past videos, you can just open an anaconda, activates the YOLOv5 environments, go to the YOLO folder, and what you need to do is just to modify the code that could run your own custom training models, and then of course you can just do it, and this is the result. Congratulations, now you should be able to perform a custom trainings and detections. I will put this manual in GitHub. What you need to do is simply following all the instructions showing in these videos and the notebook. Just in case if there are any problems or any additional videos that related to YOLOv5 that you want me to create, please feel free to leave me a comment. I will try to create one. Finally, again, I would like to thank one of my fans to support for these free videos content. Hope you enjoyed it. See you in the next video. Bye bye.